the Google Classroom. So did you get the syllabus?
Yes, ma'am.
Okay. So let me show the presentation for today's class. So this is the syllabus. Let's discuss the syllabus first. So the syllabus consists of 5 units as other course syllabi. So unit 1 is introduction part. So in that we will study some terminology, basic structure, control system problems. Then the next topic in unit 1, which is most important, is the mathematical modeling of various types of systems such as electrical system, mechanical system, hydraulic system, pneumatic system, etc. And then we will study some aspects of potentiometer, which is an industrial control device, potentiometer, tachogenerator, DC and AC servo motor. And then another important topic in unit 1 is the open and closed loop system, their merits and demerits. Then in unit 2 we'll study about transfer function of linear systems, then block diagram representation, block diagram reduction techniques, block diagram transfer function of servo motors, field control servo motor, armature control servo motor, etc. Then we'll study about signal flow graph, construction of signal flow equations and Mason's gain formula, construction of signal flow graph from block diagram and vice versa. Okay, unit 3 we will study about test input signals for transient analysis, time response analysis for first order system, time response analysis for unit step input, unit ramp input, unit parabolic input, time response analysis for second order system, okay, and similarly time response for unit step, unit ramp, and unit parabolic inputs. Then we will define the performance specifications in time domain, difference between types and order of a system. This is very important. Steady state error and error constants, static error coefficients, steady state error for different types of systems. In unit 4, we will introduce the concept of stability, necessary condition for stability, Routh stability criteria, Hurwitz's stability criteria. Then we will proceed for root locus plots, examples, general rules for construction of root loci, analysis of control system by root loci, sensitivity of the roots of the characteristic equation, and relative stability analysis. In unit 5, we will study about the relationship between time and frequency domain. Then we will study something about procedure to plot polar plots for some standard type functions, relative stability, phase margin, gain margin, the calculation of phase and gain margin from polar plots. Then we'll study about Nyquist plot, Nyquist stability criteria, relative stability, phase and gain margin from Nyquist plot. Then the most difficult topic is Borde's plot, then phase and gain margin from Borde's plots. procedure for drawing Bode's plot, then constant M and M circle and Nichols chart. The text and reference books are, the first book is the textbook, and it covers the whole syllabus, which is I.J. Nagarath and N. Gopal. The name of the book is Control Systems Engineering. The publisher is New Age International Limited. So you can buy this book for Control Systems Engineering. It's a very, very good book, and it covers all the syllabus. So I would recommend you to buy this book. Other books are by M. Gopal, Control System Principles and Design. This is Tata McGraw-Hill book. Another book by M. Gopal, Digital Control Systems and State Variable Techniques. This book is good for Control System 2 course, Advanced Control System, which you will study in, I think, your 7th or 8th semester. Then another book is BC Ku, and the name of the book is Automatic Control System. Another book is Ogata, Modern Control Engineering book, published by Printers Hall of India. So textbook will remain I.J. Nagarath and N. Gopal, and rest of the books are reference books. Okay, so this is your syllabus. What I would like you to be aware for this course is that this is a very, very mathematical course, and you need to brush up your mathematical skills. And the prerequisite for the course is mathematics, basic mathematics, Laplace transform, etc., and signals and systems, which you might have studied in your 4th semester. Okay, so this is a very mathematical type of course, a bit difficult course. Excuse me. So, and I will be solving a lot of numerical problems in the class. So you better make a separate notebook for control system course, because you will be solving a lot of numericals. It's not a theoretical course, it's a totally numerical course. The exam papers, assignments, all will have a lot of numerical problems, right? So I would advise all of you to make register for um, control system course, and note down all the numericals I give in the class, and try to solve the problems I give as assignments. Most of the time I give in the exam whatever I covered in the class. I am not very keen of giving you very difficult, if you are, what I am trying to say here is that if you are regular in the class, and if you are taking the notes, and we are alert in the class and attentive, give attention to the lectures and the numerical problems I am solving in the class, then it is going to be a very, very interesting course, and you will enjoy the course, that I can guarantee. But the only requisite for that is that you give your attention, and it's a very interesting mathematical course. I really enjoy teaching, and my area of research is also control systems. So I really enjoy teaching this course, but I am very also fond of getting attention of my students. So I would like all of you to be alert in the class. That is the only my request to all of you. And otherwise, it is a very difficult course. It's not easy. So let's start with the course. I'm giving you the presentation. Can you see the presentation, class?
Yes, ma'am.
Okay, so we'll start with general discussion on control systems. So the points which we will cover in this part of the Unit-1, which is control system and design and principles, response characteristics of control system, different configuration of control systems, control system analysis and design objectives, overview of modeling and design process of control systems, computer aided design, some history, implementation and technology, examples, and course description. Okay, so basically, what is control system? Okay, control is whenever some quantity such as temperature, altitude, or speed must be made to behave in some desirable way over time. In other words, control makes some object behave in desirable manner. Okay, so as the name suggests, the name is self-explanatory that it is basically a control. So control is when we want some aspect, some object to behave in a desirable manner, then we say that it is a control system. Okay, so a control system consists of subsystem and process assembled for the purpose of controlling the output of the process. For example, a household furnace produces heat as a result of fuel consumption. In this process, subsystems called fuel valves and fuel valve actuators are used to regulate the temperature of the room by controlling the heat output from the furnace, right? Other subsystems such as thermostats, which act as sensors, measure the room temperature. In its simplest form, a control system provides an output or response for a given input or stimulus as shown in the figure. So input is a stimulus, which is the desired response. This is fed to a control system, and the output response is the actual response. So that we will see if it is the desired response or not. Okay. So a real life problem is that water inflows, then desired temperature is fed to the water knob, and the sensor on the skin measures the water temperature. Then the water inflow is fed to the shower, water temperature is measured. According to the skin sensation, water knob is moved in another in clockwise or anti-clockwise direction. So this is a very relevant example of a control system. The geyser in your bathroom, which gives you the water for bath. So what you do, you open the tap and you sense the water temperature, and you turn the water knobs in either in clockwise or anti-clockwise direction, depending upon the temperature your skin senses, right? So in this case, the skin sensation is the feedback, is the error detection, right? So how much temperature you want you at your skin, that that will determine the amount of taps you will open for hot and cold water, right? So water inflow is manipulated so that YT is approximately RT. YT is the water temperature output temperature, and desired temperature is the RT temperature. So what we are doing here is that we are comparing the actual water output temperature to the desired water input temperature, right? So, and we are eliminating the error, the difference between the two, by opening the water knobs. So this is one of the very relevant example of a practical real life control system. So what is automatic here? So automatic can be an embedded control unit where operator has been replaced by an electronic system, right? So if you are um, turning on and off the knob or the control valve by yourself, then it is a manual control. Or you can substitute, you can replace the operator by electronic circuit, which is embedded control unit. In that case, control is now automatic. It is accomplished without human intervention. So if you are getting your desired output without human intervention, then it is called an automatic control system. And mind you, we are going to study about automatic control system, not manual. Okay, so graphically, if you want to describe a control system, I would like all of you to draw this diagram on your register, on your dedicated register for control system course. Okay, so please, I'm giving you 5 minutes time. Draw this in diagram in your notebook and draw this diagram in your mind also, because this is a very fundamental, very useful diagram for first basic principle of control system this diagram describes. Okay, so try to remember each and every part of the block diagram and draw it on your notebook also. I'm giving you 5 minutes time. No, screenshot is not necessary. I will be giving you PPTs. I will be providing the PPTs. But what I am trying to say here is that in order to proceed in an interesting way through the course, I would like you to participate, है ना? ऐसे तो मैं बोलती रहूंगी, आप लोग सुनते रहोगे, कुछ लिखोगे नहीं, तो समझ में मतलब इंटरैक्टिव टाइप आई एम ट्राइंग टू मेक द क्लास. तो आप लोग थोड़ा खुद भी लिखोगे ना, रजिस्टर खोल के लिखोगे, तो तुमको समझ में भी ज्यादा आएगा और थोड़ा सा इंटरेस्ट भी आएगा, है ना? तो मैं इसलिए आप लोगों से कह रही हूँ कि एक रजिस्टर अलग से कंट्रोल सिस्टम का बना लो, क्योंकि मैं आपको इतनी प्रॉब्लम्स क्लास में कराने वाली हूँ कि आपको मतलब अगर नहीं बनाओगे ना तो डिसऑर्गेनाइज्ड रहेगा, है ना? तो आप लोग एक रजिस्टर बना लो, उसमें आप लोग नोट्स लेते रहो. जैसे मैं आपको बोल रही हूँ कि ये बना लो, ऐसे नहीं कि मैं आपको दूंगी नहीं, आपको किसी बुक में नहीं मिलेगा, ये यू विल गेट इट एवरीवेयर. लेकिन अगर अभी आप अपने हाथ से अपने रजिस्टर पे ड्रॉ करोगे तो यू विल अंडरस्टैंड इट बेटर. आई बेट यू विल अंडरस्टैंड इट बेटर. ऐसे बाद में करने से, एक साथ पढ़ने से नहीं होता है. साथ में चलते रहोगे, इट विल बी more fun. Okay, so please try to understand what I am trying to say. स्क्रीनशॉट ले लूंगी, ये कर लूंगी, ये सब नहीं करना है. जैसे मैं बोल रही हूँ ऐसे आप लोग पढ़ते रहोगे, आपको मजा भी आएगा, क्लास में आपको अच्छा भी लगेगा, मुझे भी जरा अच्छा लगेगा ना. अदरवाइज तो मैं बोल रही हूँ, आप लोग सुन रहे हो, ठीक है, मैं रिकॉर्ड करके ऑन कर दूंगी, कर लेना बाद में. कंट्रोल सिस्टम की पता नहीं कितनी बुक्स हैं, पता नहीं कितने वीडियोस हैं. तो इट्स नॉट दैट कि मैं आपको कोई बहुत बड़ा ऐसा मतलब एवरीथिंग इज अवेलेबल, बट आई डोंट वांट टू वेस्ट योर टाइम कि मैं यहाँ पे पढ़ा के जाऊँ, फिर अलग से आप खुद से पढ़ो. यहीं पे मेरे साथ पढ़ लीजिए, अच्छे से पढ़ाऊंगी मैं आपको. So a control system is basically, the objective is to make the system output and the desired reference as close as possible. So this is desired performance, which is also called as reference. It is fed to the system. It is the input to the system. Okay, and the output is the information about the system, which is used as the output. Okay, and these two quantities are compared. This is the comparator. Comparator or error detector, because here we are giving a plus sign, here we are giving a negative sign. Okay, so here you are getting the difference or error. This error is fed to the controller. Okay, and controller gives you the output, which becomes the input to the system to be controlled. This system can be aircraft, missile, economic system, cars, etc. Okay, and that this the output of the system, which is the information about the system, is given out, and this output is fed back. This path is called the feedback path. This is the feedback fed back to the input through a comparator or error detector, and error is detected. So the key issue is how to describe the system to be controlled, which is the modeling part. How to describe the system, how to model the system. Okay, that's it. Second issue is how to design the controller, which is the control part. So basically, control systems engineering is fundamentally divided into two parts. First one is modeling, the other one is control. Okay, so what is an output in a control system? Typically, the output variable is temperature in thermal system, position and velocity in mechanical system, voltage, current or frequency in electrical system, right? So what do you, why do you, do we need control or a control system? when we build the control system for 5 primary reasons. One is power amplification, second is precision, third is remote control, fourth is convenience of input form, fifth is compensation for disturbances. Okay, so with control systems, elevators carry us quickly to our destination, automatically stopped at the right floor. We alone could not provide the power required for the load and the speed. Motors provide the power amplification, and controllers regulate the position and speed. So another real life example for a control system is a elevator system. Okay. So control systems are useful in remote or dangerous locations also. A remote controlled robot arm can be used to pick up material in a radioactive environment. This is an example of a remote control. In a temperature control system like a thermostat in a heater or water geyser, the input is a position on the thermostat while the output is heat. A convenient position input yields a desired thermal output. This is an example of convenience of input form. An antenna that points in a commanded direction can be subjected to wind, which is a disturbing force. The antenna rotates from its command direction. A feedback controller must detect the disturbance and correct the antenna position. This is an example of compensation for disturbance. Okay, so this also you can write down points you can take. So open loop versus closed loop system. So open loop is a feed forward control. The manipulated input variable is generated without measuring the output variable. Here is an example of a open loop control system. The manipulated or in reference is fed to a controller, the which a controller gives the manipulated input to the system and output is measured. There is no comparison between input and output. Okay, so input or reference is given to the input transducer, which gives input to the controller. Controller may have some disturbance, which is fed to the process. Process may again have a disturbance, and then output or a control variable is generated. A characteristic of an open loop control system is that it cannot compensate for any disturbance that add to controller's driving signal or the process output. Thus, the output of an open loop control system is corrupted by disturbances. In this also you can draw the diagram. So open loop versus closed loop control. Example of an open loop control is this. That is a toaster. The output of a toaster is the color of the toast. The device is designed with the assumption that the toast will be darker the longer it is subjected to heat, right? The toaster does not measure the color of the toast. It does not correct for the fact that the toast is not yet is white. So nor does it correct for the fact that the toast comes out in different thicknesses, right? So we have to examine the system. Assume that you calculate the amount of time you need to study for examination that covers 3 chapters to get an A grade. If the professor adds a fourth chapter, a disturbance, that you are open loop system, if you do not detect the disturbance and add study time to that previously calculated, the result of this oversight would be a lower grade than you expect, right? So this is basically 2 real life examples of an open loop system. A toaster which is not able to measure the color of the toast or measure the brownness of the toast, or examination system if the If the mood of the professor is not very good, it may add a fourth chapter to a previously determined three chapter. So you can that disturbance in the system can downgrade your result, right? So in the systems in which your control is not much there on the output are the open loop types of control systems. Okay. Now, closed loop control systems, the measurement of the output variable are fed back to the process through the controller. So this is the very important link, that is the output is measured and fed back to the input. Okay. So the reference is given to the controller, which also has an input from the output side, and manipulated input is given to the plant, which is experiencing a disturbance, and an output is generated. Okay. And output is measured and is fed back to the input. Okay. So input or reference is given to the system through input transducer to a summing junction, which is called an error detector. So which this junction detects the error and produces an error or an actuating signal. No? Error is also called an actuating signal. This signal is fed to the controller. Controller might be subjected to a disturbance 1, or it may not be disturbance, it may be a disturbance free system. So these two are summed together and given as the input to the process or the plant we are dealing with. Okay. And this plant may also experience another disturbance 2, which is detected by this summing junction, and an output is generated, which is called the controlled variable. Okay. Now here the difference comes from the open loop system, that the output is fed to the output transducer or sensor. Okay. This sensor gives an input to the summing junction or error detector. Okay. The disadvantage of open loop system is the sensitivity to the disturbance and inability to correct for these disturbance. Now may be overcome in closed loop system. However, the closed loop systems are more complex and expensive than open loop system. This is very obvious because this part we are adding to the system because we need some transducer. So this adds to the cost of the system, and this also adds to the complexity to the system, because now we will be having another block to model with. So we are having these blocks. The upper part is the open loop system, the lower part is closed loop system. So the open loop system has lesser number of blocks to be modeled. So this also adds to the complexity and the expense of the system. Okay, so this also you can draw in your register. Very important concepts, very important diagrams. Always ask in your viva or anywhere whenever you are asked about control system questions, you will be asked about these type of questions, mandatory questions in every control exam. It's the basic block diagram of a closed loop control system. Example is temperature control system, in which we have an electric furnace, and this electric furnace has a thermometer which is given to the A to D converter. A to D converter is analog to digital, because we are going to have a computer control system. So we have A to D converter, then we have an interface which is fed to the controller, which has the programmed input. So this controller can be a PLC or PLA, programmable logical array, or programmable logical controller, PLC. So this again will be given to an interface, fed back to an amplifier, fed back to a relay, which regulates the heater, and this heater is used to heat the electric furnace. This also you can draw this diagram. This is a very important example of a closed loop control system. Also called a digital control system, in which you have digital computer as your controller. Hmm? In many modern control systems, a controller is a digital computer. The advantages of using a computer to implement a control algorithm is that it can have many loops to be controlled by the same computer through the time sharing mode, right? Adjustment of the controller gains or the controller itself required to yield a desired response can be made by changes in software rather than in hardware, right? So that is another advantage. Computer can also perform supervisory functions such as scheduling many required applications, right? So these are the advantages of using computer as your controller. Another typical control system is a factory, process industry, in which we have D2A converters, which is fed to an actuator. Actuator gives the input to the process or industry. The various variables are detected by using various types of sensors. The output of the sensors are fed back to the A to D converter, and then this A to D converter is given to the control unit or controller. Okay, so this diagram also you can draw. I'll make a assignment on your Google Classroom for every day's lecture notes. What I would like all of you to submit at the end of the class the lecture notes which you are taking throughout my lecture. Hmm. So you just take the snapshot of your register, and whatever notes, if something is missed, let it be missing, but whatever number of pages you are taking the notes, that you can take the snapshot and upload it on the Google Classroom. So we'll start it by today. So and that I will be doing it right now. Okay, so I'm just giving you practice to go about the course.